Sorry, I'm very tired. Welcome back to working on the binary adder. So yesterday I built the adder. Well, I built the adder 2 days ago, but then I expanded it to be a 16-bit adder yesterday, and then I added the memory stuff. And today I need to add the memory output, so I'm going to need to have an equivalent one of those over here to read the output. So start by building some buses, which I'm sure is everybody's favourite. So it comes from here. Oh, God, I'm tired. Gotta go for a swim in the sea tomorrow as well. Hopefully I'll be less tired by then. Random detail about my life. Anyway, I just want to get on with the binary adder, get it done. Then I can, once I've done that, I can start to think about the CPU architecture more generally. Essentially, I want to get this in as an example of what like an operation on the CPU will look like, and then I can use that to decide what the architecture will be. So once I've done this, there's going to be a bunch of thinking about how best to build the rest of the CPU, basically. Because what I could do is I could build essentially the CPU piece by piece. So I could add this to the end of the data bus and add like a control unit for the CPU. So that's the first thing, right? The CPU needs to have essentially a function that reads instructions from memory, just by default. So that's the first thing I would need, I think. Or alternatively, what I can do is I can build out each individual CPU logic unit like this, and then copy paste them all together in the end. But that's more about the building order of it rather than the actual architecture of it. Excuse me. Ay, ay, ay. Why are those bottom two? Well, why are those two at the bottom? Well, not at the bottom, but near the bottom on. Why is that on and why is that on? It's not on that they're on. What's the input? All the inputs are on. Why is it only those two that are on? This bodes poorly. Indicative of a bug, let's say. Oh no, I know why. It's because It overflows all the bits out the top, doesn't it? So the overflow here should be on. Why isn't the overflow on? Ah. This may be a trifle broken. This could be a big problem with the whole design. So does it even point at that? Oh right, I see, yes, so this is what the design was. That's what the problem was, the top layer is missing that. Does mean that it is there outputting that correctly. But that's a problem down here. Yes. So the first layer is off because the input is, so two ons and an off should mean that the first layer is off. Now the second layer is off because it has an input of two ons, but it should also have the input from here, which means that there's a problem. Problem is it's not reaching there. And so it is reaching there, but it is so if it was reaching that, that would be switching off. So the actual problem is it's not reaching that side. So it's this math here. If you're just joining, I'm currently fixing some issues which somehow I didn't pick these up before I copy pasted the thing. So that's okay. So first level should be 0. Second level should be 1. Third level should be 1. Hang on. So that's an issue on this one as well for some reason. So that's still off when it should be on. So it gives the correct overflow. It receives overflow from there. There's something wrong with the. No, there isn't anything wrong with the input. Oh yes, there's a problem there. Why are there so many issues? It's very odd. Like, why was that one exclusively broken? Should all be on except the bottom one. And the overflow bit at the top should be on. Well, at least nominally it looks like it's working. Just try and bring it a little bit more in line. Apologies for the noise of my mechanical keyboard, by the way. I know it's very loud. There's not much I'm going to do about it. Ah, okay. Is it still worth it? For one tick of delay. I think probably not. Stand here, I think. And then I need to build out to here. Sorry, now I need to do it from the bottom, don't I? Then I need to go and then I need to rotate. Okay, that's the correct orientation. Leave. Why didn't it undo the Oh, that's why, because the sand dropped down. The sand fell off the bottom. So go up here and fingers crossed this doesn't ruin everything. And actually I was wrong about the rotation because in my head I thought it would be going out that way, but it's going in this way, so that's fine. I thought it would be mirrored, not rotated for some reason. Just so it can reach the memory controller. Not that it's a memory controller, it's just a memory chip. I hate that offhanding feature, and what is it? It's not the Minecraft I remember. Back in my day we only had the basic punch and left click. Ah, still a problem. So it's not going to get to the second repeater. It is somewhat less than optimal. Well, this calls for yet another repeater. Just more lag in the system, nothing to worry about. What's this? Why is that one so much different? I don't suppose it matters, but it is interesting. I guess I was having an off day when I made that one. In fact, all of the lower three are, I guess, one of a kind, I guess, before I decided to copy paste the rest of them. It needs to be purple, or rather, not purple, lime. I'm goddamn purple. Okay, so it needs to go. So I need to put output into something that's visually readable. So what I normally do to test this stuff is to put redstone lamp like this, essentially. God damn, I really need a quieter keyboard. I mean, the most annoying clacking noise ever. Right, so this will allow me to so that's the read switch, and the read switch needs its input from somewhere. Well, deleting that was singularly pointless, but never mind. Just going to rebuild it anyway, so for now, what I'm going to do is I'm going to have like that, and then So internally, what the read switch does is it zeroes every bit in the stack, amongst other things. But yes. Anyway, so I need to set up the input. So what I need a circuit. Firstly, I need to dig out more space over here. And I actually need to turn in-game volume down. A bit more than that, I think. So what I need is a circuit that switch. Well, it needs to be a switch that can be flipped on or flipped off. Basically, I need a circuit that can. Essentially, I need a single bit that will store whether or not this thing is full or not. Single bit, and now I'm just doing this to get my mind thinking. Right, I'm not actually coming up with an idea here. This is what I'm using for bits up there. So essentially this goes to a switch, something like this, that so if basically if this input signal is, if it receives an input signal, this will turn on, and if that's already on, that will stop it being written to. But if that's off, then that will turn off this. Basically, although to be honest, the right bits don't. I think if I remember correctly, it can basically permanently be set to write, or rather to read. This is the read bit, yes. This can permanently be on for all intents and purposes. What I mainly need is that when this signal turns on, so basically let's say we have this pulsar signal here. What that will do is that will mean that it can write. Briefly it can write and then it gets turned off, essentially. That is what I want. But yes, there's one more thing it needs to do, and when it gets the second signal, right? So it goes like this. It gets pulsed on for a brief bit, then it gets turned off, and then gets pulsed back on again, and that second pulsing back on again needs to turn it off somehow. I think can be arranged something like this. I think this will work. No, it won't. It will not work. Yes, so that's the problem. Oh, I know how to do this. A feedback circuit. Put like this here, and this here, and then when it's on, it can't receive input. Hang on, why is it cycling like that? Oh right, yes, of course, that's why. So it's cycling like that, and that's not ideal, to put it mildly. Does doing that help? No, it does not. What should help would be doing this. But for whatever reason it doesn't. Why doesn't that should just... It's a little odd. Hang on, that's because these are also spaced out, so that's why this should work. The problem now seems to be that it won't turn on. Perhaps unsurprisingly. Yes. That's a non-starter. Of course, there's a yes. Hang on. So if I set up a not gate here, this means is that if that's correct, if that is on, then that is off. Yes. So that part is correct. what you need is this way around. So that one there. Bear with me here. So that is on. Switching that on switches that one on. Switching that on does nothing. But that's only because I need to bring this round here. Like that. So now of course it does the opposite, which is not what you want, so yeah. By some miracle of luck, I may have just created a very janky system here, almost entirely by accident. But it is does seem to be flipping. Whatever I've done here, I've just muddled through with like pure intuition. Right, so what does all this mean? What it means is that first I need to actually test that. Hang on, is it actually doing what I'm wanting it to do? Technically it's actually not doing what I wanted to do, so yeah. Sorry about my internet. It's been terrible lately, much worse than normal. So if it's going from that, if the signal is going So logically we want... Oh, for heaven's sake, I don't know what's up with my internet. Current rate of progression, I'll have to complain to the service provider. Right. So this switch is on. What the dickens am I doing? Right. Or I should probably actually use a glass block there as a as a lossless backwards transmitter. Right, because glass blocks don't introduce any lag. Right. Now I need two of these guys and an AND gate in between them. I also need to bring this out here. So it needs to be this and that. That's an AND gate. Yes, that's an AND gate. This then feeds into a second one, like this. It needs to be the other way around, like this. So that's a secondary bit of storage that will store. So if this is on and this is on, then that will turn on. Right. That doesn't help. That is a surprisingly difficult problem. Again, what I'm trying to do is I'm trying to get essentially a bit that will turn on when this memory stack has been filled up, and then when the memory stack has been emptied, the bit needs to turn off again. So it needs to So basically, I need what. Sorry, I really don't know what's up with my internet provider. It's just, it's not normally like this. So you need a circuit that does not. Yes. Oh god, I feel remarkably stupid right now. Feeling stupid isn't going to get this circuit built though, so. So you got a NOT. Try NOT gate here. Just going to try things and see if anything works. Like that. Yes. First of all, I'm actually going to give myself more space. So yes, this first, and then let's try this NOT gate idea again. Let's try this for a second. So that switches off, that stays on, and you want. Hey, what you actually want, you want that and somebody is smoking outside. That and that. And you want. Can you tell I'm reaching here? That and that and that and that's well, essentially by doing this I can record state changes. yes, by doing this I can record state changes. Money can be exchanged for goods and services. Right, so when I turn this off, that will progress to the next level. That will count that there's been one flick of the switch. I feel like I'm making some very stupid mistakes here, but this should work. So of course there needs to be some way of turning this off up here. Now bear with me, so I turn this on, that turns that on. I turn this off, that turns that off and that on. Right, and then I turn this on again, and it repeats back to the first position. What I want it to do is when I turn it on again, I don't want that to. Essentially, I've only got this here just now that's the test. What I want is a third loop. So yes, what I want is. So what I want. I really want. Excuse me. Cringe, I know. Deal with it. This is what I want. And then I want the second one over here. Guess that should work. Second one over here, and then essentially like this. Feeding into something like this. Like this, you see. And then what I want is to bring this around. So switching that off should progress it. So you switch. So let's turn it on. This turns that on. Now switching it off should switch that off and that off. Now you see what I want is for this to stay on. So I think I want a NOT gate here. is so slow, isn't it? Right, so that's not gate. That means that when that, so you switch it on, you switch it off, then you switch it back on again. Yes, that doesn't work. Specifically because when you switch it back on again, it so now you switch it. So you switch it on once. Switching it on once doesn't lock the system down. Now this circuit here can lock the system down. Okay, so the actual problem is the output from that, switching that off. So if you do it like that instead, sorry mate, but you're making an annoying noise. Like, I don't condone this, but if your neighbour's making an annoying noise, no, it's so what are these guys called? Travelling traders? I don't want him standing next to me going, all the time. You too. It's wrecking the computer just to get that stupid llama. There's a lesson in there somewhere. At least I think the llamas are quiet, aren't they? Anyway, yes. That should work now. So that switches the first one off, on rather, switching it off switches the middle one on. I think I want to get rid of this. I think that was a mistake. Narrator, it wasn't a mistake. Maybe I want this the other way around. No, I certainly don't want it that. Alright, let's think about this logically. So you have this one on. So you want, when this one is on, you want so this one turns on when that signal switch is off. What you want is for when that signal switching off. So when that signal switches back on, you want so why didn't it work? I just put one like this. Why doesn't this work? I see why it doesn't. I'll sort of see why it doesn't work. Which again means you think that you want to have an AND gate here, or rather a NOT gate here. So it progresses to the middle one, and then you turn it back on, and it progresses to the end one. And also back to the middle one. This is an extremely elaborate circuit for what I want to do. I don't. So by my calculations, switching that off should switch that on, but it shouldn't switch that on. For whatever reason it propagates. I don't know how that works. So this. So that switch is off and slower. That switch is on slower than this switch is off. I think means you want to put a bit of delay in there. Still? Really? What? Why is switching that on? Oh, I see. That's because of that. So that also needs to be on delay. Very odd indeed. So that's now correct. That's still not working. Should just be a matter of this delay switch here, though. Yes. I swear to God, man. I swear to God. Of course, yes. That's because I need to add that there. So that at least is correct. That is solidly not correct. For reasons that are completely unknown. So there should be 1, 2, 3, 4 ticks of delay, and there should be 7 ticks of delay. 7, 8 ticks of delay going that way. I don't know, man. I don't know. Let's just slow it down even more. Oh, I actually do know. I do know. I am a knower. Yes. So actually, it's completely. There's back feedback in this loop here. That should stop it. First one switches on. Second one switches on. Third one switches on. first one gives the appearance of being on, but is not actually on. So, how much can I get away with here? Can I get away with removing these? No, I need a system that says not that to tranquilize the whole thing. So yes, what I need is a signal here. I need this to be a NOT gate. So that's where I'm going. How do I get there? Place a NOT gate. Why can I place a NOT gate? There's not much room for my NOT gate. Do this. So that is the logic. That's sorry, no, that's just a redirect. It's not important. Now, when I switch this off, it should pacify the whole system. No, yeah, because this is the wrong way around. So, right, so starting from the beginning, turn this on. Turns the first light on. Turns the middle light on. Turns the back light on. Tranquilizes the system. Okay. So the logic there is actually not too bad. Now I just need to make it into a stack. So something like this. Then that goes up a layer onto layer 2. This is incredibly janky. I'm sure there must be a better way of doing it. I don't know. That's just bad. Anyway, so input from that goes into another one of these. Like so. So that switches on. Now, when that is on, that goes that way. So it goes into one of these. Go into one of these. And then it would go once again up. Right, switch off on that side is, I think, on the wrong side, isn't it? Also, yes, that's the right side, that's the wrong side. Man, my head is aching. It's like spinning right now. So that's correct, I believe, yes. I believe that is correct. It should be correct. Then that comes from up here. And this goes obviously into a So, where does it feed in on this end? Right, so I need to do the outside loop. Welcome to the worst redstone contraption you've ever seen. So that switches that on. This should switch. Hang on, have I put those? Yes, I've put those the wrong way around. It's a NOT gate, isn't it? So this actually needs to be NOT. So that doesn't work with that. George is getting angry. that's a NOT gate, and it goes and so that's the mid layer on. It's a real faceplant moment to the double NOT gate. That is an incredible faceplant moment. So this needs to be a NOT gate here. If I can just remember how NOT gates work. So I think I'll put that back there. Get rid of that. So that doesn't help. Ugh. Idiot really struggles to play Minecraft. Mentally, I legitimately feel like I'm dying right now. Just figuring these circuits out for whatever reason has been exhausting. Should work now. Middle one is on, top one is off. Middle one is off, bottom one is off, top one is on. Yes. They're all off. So that circuit is sensitive to what I wanted to do. What an ugly circuit there is too. Oh my word, it's so ugly. Let's try and neaten it up. That's a bit neater. I'm going to try something a bit different actually. I'm going to try encasing it in glass. Just like an aesthetic decision. Now, if you're new here, you might be wondering what this whole circuit is for. To which I respond, it's for none of your business. No, I mean, it's, I'll explain in a second. But I think I'll explain and then I'll get out of here because I've legitimately got a headache now. And I've got to go for a swim tomorrow. The sea is freezing. Need to be well rested. Alright, so what's this horribly complicated thing for? Also, it's like, it takes up practically the same surface area, it's just that it's, yeah, that's stupid. Oh well. So what's it? So firstly, so this is a binary adder, right? It takes two 16-bit numbers and adds them together. Now the thing here is that obviously I can only read one number from memory at a time, so it has to read one number from memory, store it somewhere, then read a second number from memory, and then add them together. So what it does is it reads one number from memory, it stores it in this stack here, which is a 16-bit register, I guess you'd call it, or memory address or whatever. And then when it gets the second number goes around here, and it's a binary adder, and they get added together. But what I need is a way of tracking whether there's a number in here or not, right? Because it doesn't automatically know if it has a number stored in here. So I need a way of tracking whether or not there's a number stored in here, and that's what this is, right? So this will start in the state of off, which corresponds to no number stored in here. Now, when the thing is switched on, right, that will go into a state of on, which corresponds to a number is being stored on here, right? And then when I switch it off, that will go to the middle layer being on, which corresponds to a number has been stored on there. And then when I go to that will go to the top layer, which also corresponds to a number is being stored on there. But, and that's switching it on twice. So essentially, every time I switch that on, it's equivalent to receiving. So when it receives a number, right, it will be switched on. This whole thing will be switched on. So that's when it gets the signal here, basically. So when we get to this top layer being on, that's when we get a number which goes in, and it goes down this side here, right? So once that has been processed, we switch off, and the system reverts back to nothing, which means that this is now free to be written over again. So essentially, what this thing here is it's an apparatus that is sensitive to the switching on or off of this signal here, right? Basically, it can count 3 switches on or off. That's all it is. And using that, I will be able to time whether or not this register needs to be overwritten or not. But yes, I'm going to call it here.